Let's take a look at some of the options you have when wanting to control a light's shadow. When lighting is seen in the real world, shadows and how they're controlled are pretty straightforward. They get their look primarily from the intensity of the light that's creating the shadow and the angle that that light is in relation to the surface or surfaces that it's hitting. There's not a whole heck of a lot that can be done about that. The shadow is what it is. Such is not the case when working with computer-generated shadows, where you actually have quite a bit of control in tweaking and adjusting your shadow's appearance. To review some of those options, I'll be using a file named Controlling Shadows. You can find it in the Working Files folder for this chapter. The scene consists of a logo I've created, in addition to a floor that'll be used to display the shadows cast from the objects above the floor. There's also been a target spotlight added to the scene, which we'll use to generate our project's lighting. Let's render things up so we can see what we're starting with. With the perspective viewport active, up on the right-hand side of the toolbar, I'll click Render Production. Okay, we're missing something pretty important here. Our scene is completely absent of any shadows. Lights in 3ds Max, as we've previously discussed, aren't designed to cast shadows until they're specifically told to do so. And without that additional shading in our scene, things frankly come off looking a little drab and uninspired. Let's get a few shadows in place, and we'll see if that makes any difference on how things turn out. To activate the shadows on our spotlight, we've got a couple different ways that we can go. In closing the render, we could select the light and head over to the Modify column. Once there, we could activate the On option in the Shadows category. Another way to go would be to simply right-click in the view, then in the menu that opens on the upper left-hand side, turn on Cast Shadows. Okay, let's go ahead and render our scene again, this time using the Render Last command, the keyboard shortcut F9. Check out what simply activating the shadows did as to the way the scene looks. It's crucial to realize that shadows play a very important role in creating realism in a scene. They help not just to define the placement and position of your objects, but they also play a huge role in adding both depth and dimension to your work. Let's go ahead and close out our rendered window. Now, watch how things would change if we simply move the light. Before we do that, though, it'd sure be nice if we maybe had a little more interactivity with our shaded viewport when it came to controlling our shadows. If your computer's video card is equipped with the necessary hardware shading, you can actually instruct Max to display the shadows in your scene directly inside the shaded view. Here's how you can do that. In the top left-hand corner of the perspective view, we'll click on Realistic. From the menu, we'll access Lighting and Shadows, then off to the right-hand side, turn Shadows on. If we wanted to see the actual light that we've created in action, there's a control for that too. Back under Realistic, this time we'll choose Lighting and Shadows, then Illuminate with Scene Lights. Okay, in moving our light, let's activate the top view and slide the light to the far left side. We can see that updating both the lighting and the shadows directly inside our shaded view. Let's open our rendered frame window and we'll render again. Quite a difference that's made moving the light from one side of the scene to the other. Let's go ahead and close our render and we'll put our light back to where it started. Okay, let's talk about what you can do to control the shadow. To best optimize the way that we view things, let's resize our perspective viewport. We'll do that by placing our mouse where the viewports come together, holding down the left mouse button, then lifting up and over to the left. Once in position, we'll activate the Active Shade option for the perspective viewport. Up at the word Perspective, we'll choose Extended Viewports, then Active Shade. Max offers a couple of different types of shadows when lighting a scene. We'll start by first looking at the shadow map. Now, a shadow map shadow is just that. The shadow that's created is actually a map or picture of a shadow. It's based on pixels, in other words. It's the shadow map shadow that's the default shadow on any 3ds Max standard light. Back in the active shade, notice how dark the shadow is. We can control that under the Shadow Parameters tab. Just to the right of the color swatch, you'll see the density control. Let's take that value from 1 to 0.7. This will have the effect of lightening up our shadow. Let's try a value of 0.3. And we'll take the setting back to 1. The color of the shadow can be controlled by the color swatch. Let's change the shadow to green and we'll see how that looks. Now, not very realistic, but it does come in handy in certain special effects situations. Let's see how things would look if we change the shadow to instead blue. Then we'll click Reset, taking the shadow back to black. You can even add a map into the shadowed area. Directly below the density setting, click on the button that says None. When the browser opens, let's choose a procedural noise map. Procedural meaning that the design in the map is created by math and not an actual image. To remove that map, we'll simply right-click on the button and choose Clear. You also have some additional controls in the Shadow Map Parameters section. You'll find that tab directly below where we've been working. In here, you can control the overall quality of the shadow. In other words, just how clean or how well it turns out looking. That's controlled by the size value. Let's take the size to 256 and we'll see how that changes the way the shadow looks. Lowering the map size starts to make the map that's being used to simulate the shadow break down, creating a lesser quality result. The lower you go with the number, the worse the problem gets. Let's try a size of 128. With the map now being so small, we've really deteriorated the quality of the shadow. Let's take the map size back to the original default of 512. Now with the size, the higher the setting you use, the better the quality of the shadow. That does, though, come with a longer render time, so it's a little bit of an adjustment back and forth. For comparative purposes, let's try a size of 1024. You can see how that's improved the quality of the shadow from its original 512 setting. If there's ever any concern as to how far or close the shadow is from the object that's casting it, you can adjust that by using the bias. In the active shade, take a close look at the left-hand corner on our purple object. You can see that there's a little spacing between the shadow and the object itself. If we wanted to move that shadow maybe a little closer to the corner, we could lower the bias. Let's take the setting down to 0 and you'll see the difference. You can now see how the shadow's been better nailed down to that corner. It's also possible to soften the shadow's edge. That's done with the sample range setting. Let's take the value to 10 and we'll see how that looks. The higher the value, the softer or blurrier the shadow gets. Let's try a setting of 20. Now, this too will increase your render times, so take that into account when making your adjustments. So that's the Shadow Map shadow. The good side, it's quick to render, and because it's map-based, you have some control over the shadow's quality and the ability to soften its look. On the downside, though, a couple of things that I've yet to mention. The first is that a Shadow Map shadow creates no shading differential with distance. In plain English, that means that the shadow remains looking the same, no matter how far the shadow's placement is away from the object casting it. So there's no blurring effect with distance, something that you typically get in the real world. The other thing about Shadow Map shadows is that they don't recreate the proper shading that you'd get with transparent surfaces. Their shadows, being map-based, remain solid throughout their shaded area. So when lighting transparent surfaces, like glass or lightweight plastic, you'll be better served by choosing a different shadow type. We'll take a look at a couple alternative shadow casting options in the next video.